Hi everyone, I'm Hunar. In this video, I'm going to show you an early demo of our machine learning tool, which we call Braifun. Braifun is based on a novel machine learning algorithm, which we call PHUN, which stands for Predictive Hebbian Unified Neurons. This algorithm is characterized by being efficient and is able to learn online. I mean, in real time, and it really needs much less data to learn, unlike deep learning systems, which they require a huge amount of data, and they are iterative in nature. So you have to run a lot of epochs for the learning system to learn anything that's useful. But in this algorithm, you only need to run for few epochs. This is the user interface of Braifun. It may change when we release the application, but for now, this user interface is experimental. This panel have the hyperparameters of the learning algorithm. So basically, the data type. So right now, the algorithm can learn from any time series data. So we implemented learning for text and audio, and we will follow up with images as well. So basically, I'm not gonna go through all these parameters, but I'm gonna show you how efficient is this algorithm or this application is. Here I'm not gonna load all the data because audio data can be very large, so I will just try to load a few seconds of the audio. So 100,000 data point, over 100,000 data points will be equal to like few seconds of audio data. Let's update the parameters, and now let's load audio instead of text. Let's load this accidental tourist. So the audio was already loaded, and now we can train. So it finished training in just few milliseconds, and then now you can generate audio from that. So by just pushing this, sorry, we have to increase the number of samples. Then let's plot the learned data. So as you can see, it generates a wave that looks like audio. So let's train that for another epoch. So now I have trained for another epoch, and let's generate new audio. As you can see, now the audio is more detailed, but I'm not, I could push start sound to hear the generated sound, but I'm not gonna do that because I'm wearing headphone, and it's not a good idea when you generate sound and wearing a headphone. It may be very noisy in the beginning, or it may contain some unpleasant frequencies. But let me train it again. So you can incrementally train on it. I mean, you can change these parameters so that your learning algorithm can learn every feature in one epoch, but you shouldn't do that because the amount of the audio that we loaded is only few seconds, and it can overfit if you do that. So just in the beginning, it's better to learn a little bit gradually. So let's train again, and let's generate the output. As you can see, when I trained again, the output is now more like a wave, an audio wave. So if I play the sound, it may look like a musical sound right now. Let me be a bit cautious before running the sound. So I'm hoping that you can hear the musical sound. It learned to generate this sound from scratch actually. And you can generate infinite number of musical sound, and you can do that for any voice type. So let me stop that. So currently this application is it has ability to generate, and it has also ability to detect using the same algorithm, but the detection part is a bit lacking behind the deep learning systems. As you know, that deep learning systems are very heavy on accuracy benchmarks, and it has been a decade since like many people have been working on improving the accuracies of deep learning. So it's not a fair context to compare the accuracy of this new algorithm with the deep learning, which have enjoyed a decade of fine-tuning and incremental increase. So currently the accuracy for detection is not good. That's what we are trying to improve. But once we improve that, it will be ready for release. And we already have ideas about how to improve the accuracy, and it just needs we need some time to implement that. But once you do that, the value of this algorithm is its efficiency. As you have seen, like it generates sound in just few milliseconds. It learns from them, and to our knowledge, that the state of the art sound generation is currently done by a deep learning algorithm, which they call it WaveNet. But WaveNet actually it requires a lot of time to just learn from few for a few seconds of sound, and even for generation, if I remember correctly, it generates 1 second of sound, but after like many times, after training for many times. And nowadays they have improved the WaveNet algorithm, so it can generate sound in real time, but they do that after parallelizing algorithm and optimizing it and putting it on powerful GPUs, while this algorithm is actually runs on CPU without I haven't done any parallelization yet. Although the algorithm is embarrassingly parallel, but it's so efficient that I just till now didn't need to do that. It didn't need to bother with parallelizing the algorithm. Anyhow, I'm hoping that this application will be useful for machine learning communities. This is the early phase demo. I was just showcasing the generative power of this algorithm, and hopefully in later videos I will show you more demos once we add more features. So thanks a lot for listening.